Yes.
Good evening. This is Geeta Mallikarjunan, CEO of HME, and on behalf of Hyderabad Management Association, I welcome you to the MSME program on the topic Digital Manufacturing, Agile Option for the New Age by Dr. Guruprasad Rao, Direct Faculty of Design, Dr. Vishwanath Karad, Maharashtra Institute of Technology, World Peace University, popularly known as MIPWPU. I also welcome our office bearers, MC members, and all the members who have registered for this program and also watching us live on Facebook. I welcome our convener, MSME, Mr. Peddi Rajendra Krishna Prasad. I also welcome our speaker, Dr. Guru Prasad Rao. And with this, I request our president, Mr. Ramchandra, to take the session forward.
Thank you very much, Geeta ji. I greet everyone a very warm welcome and good evening to all the August gathering from my members of HMA, students, members in the industry. I feel it's a great privilege that we have with us Dr. Guruprasad Rao Garu, who's a man renowned, very much renowned in this particular subject of today's topic, which has been proposed as a digital manufacturing. I think that is today's probably the intervention in the industry 4.0 or whatever we call, with several innovative things coming up every day. And I think we have a right person to talk about this subject to all of you for the benefit of all our members. I deem it a privilege, sir, to welcome all of you once again, and it's really a heartening evening today. And I thank all the members present for sparing the valuable time to sit down here across wherever you are and to listen to the talk, which probably by end of the day, end of the session, we will be enlightened about the new trends in the manufacturing sector, especially, and probably see how best it can be also be, brought down to the MSME level also. I don't know the cost part, probably sir will be giving a detailed information about it. I would congratulate Mr. Rajendra Prasad Garu, our convener today's program, for having brought Dr. Prasad Garu to our fold, and other members, and Mr. Murali Raj Garu, our senior member, and other members present. I think today's topic is very relevant, as I mentioned earlier, and I think we'll have probably a very big learning session. As the president of HMA, I have an August honorary role of talking a little about it. There are quite a good number of members who keep joining us. So for some, it may be a repetitive sort of thing, but for quite a number of them, probably we'll be adding some value to them to talk a little about HMA. HMA, as you know, is a unique body, basically focusing on management, development of management in every sphere, whether it is in the college or in business, or whether it is in the industry or wherever it is. I think management is so important, and today everybody talks about doing the best practices, adapting the best practices, and looking at the best practice being adapted by different organizations, and then trying to adapt them in your respective places wherever you are. And it is, I think, an unending process. It keeps on and on and on. So we at HMA, we try to do this particular thing, try to propagate all about management to the extent possible. As I said, it is very unending. But to start with, we have been focusing more on the students, the young managers coming out of the colleges, finishing their MBAs or BBAs, the young engineers and the practicing managers, and also to the faculty in trying to enrich their capabilities further. We have been conducting several programs, a program like what we are doing today, probably addressing the MSME sector. In fact, very few days ago, our Prasad Garu has organized a similar program for the MSME sector on the challenges, etc., and all the marketing aspects. And prior to that, we also saw what are the legal aspects in the marketing, where Mr. Murali Raj has delivered a valuable lecture. This sort of programs we keep doing on a regular basis, and we target the students, and as I said, the students as well as women and other sector also. And to the students, we have a very impressive program called as IRP, Industry Readiness Program, where we feel that we try to act as a small step or a small bridge to see that the connect between industry and academy is brought to, it is made more comfortable. It is a 42-hour capsule. We do it in the weekends without disturbing the regular curriculum. And the fee charge is very nominal, thanks to the sponsorship that we get, especially for this program from Bambino Industries. And that's how we are trying to see that we keep on giving value addition to the students as well as the MSM sector of the practicing managers. In this connection, I also would like to say HMA also conducts a program for awarding people of excellence who have been excelling in their field, whether it's in the MSM sector or in the small scale sector or even in the large scale industries for the women academicians, and see that they get rewarded for their work by giving an award through some dignitary. Last time we had people from the central ministers, even the governor, and I think it's one of the flagship activities of HMA. So we also are now focusing on this particular program, which will be held somewhere in the month of March. We are requesting all my member friends to identify such people who are eligible so that the deserving get the best award. With this, I probably will hand over to Dr. Gurprasad Garu. So today he's going to talk about the digital manufacturing methodology or process. He'll give a lot of insights into that. I am also a mechanical engineer, but I think it is a new subject. I'm of the older generation. My baby sir will probably be able to give us several insights into this, how exactly it helps in improving the manufacturing process, the use of IoT, use of 3D machining, etc., all that, 3D printing, all that. I'm sure it will be a learning experience for all of us. He is a very senior person, having great experience of more than 30 years in the industry, in the academy. He's himself a doctorate in the design field. And I think his lecture would be of immense value to all of us. So we look at you for your wonderful speech today. And I take the pleasure in once again extending a warm welcome on behalf of HMA and on behalf of all the members present and our management committee. I'm sure we will have a good learning session. Thank you once again for accepting our invitation. And I hand over to Mr. Rajendra Prasad to please talk a few words about the background of our eminent speaker for the benefit of all our members. Thank you very much. Namaste.
Yeah. Thank you very much, sir. Yeah. Respected our HME President, Sri Ramchandra Garu, and our Vice President, Jayavant Naidu Garu, and our Honorable Secretary, Kuchi Chandrasekhar Garu, our Joint Secretary, Devendra Reddy Garu, and our Treasurer, Mohan Rao Garu, and our HMA CEO, Geeta Madam, and today's evening guest lecturer, Dr. Guruprasad Rao Garu, and my fellow esteemed MC members, and then our very respectable HMA members and today's evening participants, and ladies and gentlemen. It's my honor and privilege to welcome you all for today's evening webinar on digital manufacturing and agile option for the new age by Dr. Guruprasad Rao Garu. Yeah, you all know the art of making things evolved since the industrial revolution. With the advent of computing and high-speed communication, we can achieve extreme agility in manufacturing with EOQ, economic order quantity of unity, CNC, robotics, and 3D printing technologies from the manufacturing trinity to make anything in future. 3D printing has been called the next big thing since 1986. It has been evolving since then and has held a curiosity and interest due to the agile fabrication capability. The application of 3D printing plenty in the manufacturing sector like automobile, aerospace, defense, surgical device, implant, construction, jewelry, etc., jewelry sectors, etc. We can see its application space is also expanding now. Well, we'll all learn more on this particular subject from our guest speaker, Dr. Guruprasad ji. Now it's my honor and privilege to introduce our guest speaker by reading his profile to you all. Yeah. Sri Guruprasad Rao Garu is the director of the Faculty of Design at Dr. Vishwanath Kharat, MIT World Peace University, Pune, Kothur campus. He mentors two design schools, namely the School of Design and School of Fine Arts. His current focus is on shaping the state of the art design school to create future design leaders in product design, like UI, UX design, visual communication, fashion design, interior design, graphic design, instruction design, and digital media. Dr. Raoji is a technocrat with about 34 years of experience encompassing industry and academia. He holds a BE mechanical degree with a PG in tool engineering from GTTC, Bangalore. He did a Master of Design in Product Design from Indian Institute of Science, Bangalore, and did his PhD from IIT Bombay. For his terminal degree, he worked on a medical application on 3D printing. He is a trained Bal Bhavan educator and has taught painting at Jawahar Bal Bhavan. He has undergone training at Osaka, Japan, in product design under AOT's scholarship. His industrial assignments include Titan, Tanishq, Crompton, Wheels, Imaginarium, and presently at MIT WPU, Pune. He joined MIT WPU as a director, faculty of design, and oversees the School of Design and the School of Visual Arts. He was CEO, director, mentor of Imaginarium India Private Limited, leading 3D printing company from Mumbai. He has taught the design at IACT, NFT, NIFT, IACATE, and NTDF. He was a professor and head of project office, IACD, Jaipur. He is also teacher courses on emerging technology and the impact of SPJPMR and Somaya Business School. He is also mentor at KIT TBI Bhubaneswar and guides startups. As an accomplished product designer, he holds an utility patent and 150 plus design registration. Okay. He has received many awards for his fine arts and product design efforts, including 3 gold medallions from World Gold Council. His research interests include product design, prototyping, Industry 4, 3D printing, and its application, design management, medical devices, and design assembly. Dr. Rao is associated with many industrial bodies such as CII, FICC, PC, and NASCOM, BIS, IAMF, Atal Innovative Mission. Presently, he is part of member and CII National Committee on Design at 2019 to 2021. As CII Conference Chairman, he successfully led CII 3D Printing Conference at 2019. Mumbai as the Conference Chairman. Currently, he is part of Vernaculum Task Force of Additive aim to promote design thinking across the country. He has served as a jury in many business and design and innovation. Challenges of CII, ASME, AICTE, BIR, TBI. He has recently engaged as a jury for the excellence in Industrial 4 implementation for PICI. He also contributed as one of the judges for ASME iShow 22 Hardware Innovation, which got recently concluded. He is presently a super mentor at KIT TBA Bhubaneswar. Dr. Rao is a passionate speaker and loves to talk about design, aesthetic, and innovation, digitization manufacturing, additive manufacturing, 3D printing, design for AM, medical devices, innovation. Great, sir. It's my honor now to welcome you, sir, for taking over the session. Before that, I have a small request to my friends and participants that any of don't disturb in the presentation. This presentation is got a video embedded PPT presentation, so that any queries and questions you please put into the chat box, or at the final of the webinar, I may address the questions to speaker, or you can introduce yourself and put your questions to him so that he'll answer to you. Thank you. Sir, it's mic is yours now.
Thank you very much, Rajendra Krishna Prasad Garu.
Yeah, thank you.
My good evening to all the members, and in particular, Ramchandar V. Garu, the President of Hyderabad Management Association, and all the office bearers, CEO Geeta Mallikarjun, Madam, Karthik, who did the trials yesterday, and he is joining and supporting us today, Karthik from HMA, and all the listeners, members, students, faculty who might be part of this gathering. It gives me great pleasure actually to share my life journey with this new technology, which has been, called as next big thing since 1986. It's called as next big thing since 1986. That means, you can see we still are trying to see what it can do for us. I've been talking to industry students, all enthusiasts, maker places also, that this technology, one should understand the pros and cons, why it is good for me, or is it good for me at all? So I'm going to try to demystify the technology. Like any other technology, it has to help us in improving our lifestyles, and it has to remove pains and make life better. Like Phillips used to say, let's make things better. With this, I would like to start sharing my screen. Let me try if I can do it. Hope it works now. The COVID has been made us the experts of working with this media, the Zoom. And can you see my screen? Is it in
Yes, sir.
full screen?
Yes, sir. Yes, sir.
Okay. So what I will do, I will try to cover as much as I can very fast, because there are a lot of concepts to be shared. And so welcome to this evening lecture on digital manufacturing, an agile option for new age. Why I'm calling it as new age, let me explain that also as we go through. Let me start. Let me find a place where I can see this movement of the slide. Yeah, it moves now. So once again, thanks to Hyderabad Management Association for this wonderful opportunity. We all know, I know startups, they start finding some kind of challenge they take up, and they want to do things. Many times, the challenge, they'll convert that into what is known as a basic idea that will tell others, well, this probably works. We call this as proof of concept. So proof of concept is that which is going to demonstrate the potential of a possible idea that can be commercialized, So that is the starting point for our entrepreneurs. If we say MSME and various entrepreneurs we also have, I think, startups, and there is a startup wave in the country. So we need to understand the startup people, what they should look for, before they can go and make things. So as Rajendra Garu put it, art of making things. Before making things, we have to know what to make. Very important. Many times, what is important for commercialization is not a concept of proof of concept. It is a product which can be sold and you make the first money, the first profit, and maybe a set of them, which has got very basic features, but still useful. And we call that as MVP, minimum viable product. That is, at a basic level, you can sell and make some money. That's very important, you know. But today, there are a lot of versions of these, and actually, the person who started giving this name MVP is Eric. You know, he has written this book, Lean Startup. Probably many of you know about this book. If you have not, it is a good time. You take a look at it. Very important. So, what exactly entrepreneur does? An entrepreneur will identify a problem and he checks the idea with a proof of concept and goes about building it. So, think and build. It is a cycle. You know, when you build and you check whether this is going to meet the requirements or not of the user, then you have to take it to the user, and user will tell you something else, and again you rebuild. So this goes on, and that's why we have so many versions, be it software or products. They keep on coming. There is nothing like a best design. You know, there's always a better design that is coming, right? And so it's very important that MVP, we should know what is MVP is. So let us take the example of a balloon. A balloon, if it is filled with air and left, it moves because there is air coming out from the backside. So there is a reaction. Action and reaction are equal and opposite. So balloon goes forward. So this is a concept. How to make that into a proof of concept? You can see they have taken a bottle, they have put some wheels, and you have put a balloon. And there is a small straw which is going, you know, which is going to give you, it is going to impede the flow of air so that it gives some traction. Now, as it moves, you know, you get some kind of movement. Now, this could be a very great toy, you know, for children, even for science students, in order to understand what it is. Now, this proof of concept, I cannot sell and make money. You know, I cannot make money out of it because it is not in a form which can go to market. You know, that is very important, you know. So you can see here, this proof of concept is so fragile. It may work now, it may not work, it may get broken. But minimum viable product is that which takes the same principle as proof of concept, but in a form factor which is more attractive, more manageable, and which will last longer. You know, so you can see there is a toy which is using balloon, and there is a small wheel which are made up of, you know, Lego bricks. And there is one version and there is another version, a longer version, a shorter version. Maybe one can be called as a lorry and one can be called as a car and driven by this air balloon, right? And I think that is the important thing, you know, for any startup in order to get going. Soon after proof of concept, you should go ahead and make a minimum viable product and sell, make money. You know, entrepreneurship is all about converting creation to wealth. Very important. So as we move, we can see some of these examples, how to build a minimum viable product and how not to build. You know, the first one is not a good example, right? Why it is not a good example? Because here you cannot start anything with a wheel and a chassis, and as it moves, you can see how you cannot end up with some from a cycle to a car. It has to have a platform and you play around on the platform. So there is something called as a basic chassis or basic platform on which a product is built. Okay. And this happens with any product. It could be a jewelry, it could be a food, it could be a software, it could be a car, e-vehicle, two-wheeler, anything like that. So you need to have that kind of a platform which is going to help you, build, and you can have different versions going on further. So it's very important to understand we identify unmet need or a problem in order to start. And need is that which is both important and unsatisfied, is called as unmet need. Okay. Unmet needs are opportunities for the value creation. That's what startups have to focus on actually. And more important and less satisfied, a need is greater opportunity. That is the whole thing. Identifying that becomes a very important thing for the entrepreneur and the startups. So if you look at the the whole space of unmet needs, there are two types of unmet needs: real unmet needs, perceived unmet needs. So we have to focus on real. Perceived is, after all, imaginary. So observable, discoverable need, iterative evolutionary need, latent or creatable need, disruptive and revolutionary need. And so it is very important to focus on all this, and you will need a maker. Ideas are sometimes killed. Idea which is not made properly gets killed, right? And you need a good maker to make your idea take wings. And that's where our subject today, digital manufacturing, will come into our rescue. When you try to build a minimum viable product, there is a whole lot of valleys of death. One of them being you're not able to, you have a proof of concept, but you're unable to create a product which can be sold. Somehow it is not coming together. Integration of electronics, the power train or whatever, you have, those things have to come and should be given in the hands of the user in a form factor that is attractive, that is safe, that is usable, and it is a delight. A product is an experience, and it is very important, as Dieter Rams puts it, a product has to be honest. If it is something which is looking very jazzy and it is not honest, it is not meeting, it is not giving you the basic function of a what it is meant for, then probably we have not done enough justice. A user will reject it, right? User rejects a design where designer doesn't understand user, then there's no fit. So it is very important to make a design which is honest. So it is very important in the whole, gambit of attracting, winning, retaining customers. Digital manufacturing plays an important role there. That's where we need to know how to make things. Otherwise, it's impossible to meet those needs. You want a chair, you have to make how to make the chair. You should know what material we're going to make a chair and what exactly customer wanted in a chair. So all this will go, and after all that, you need to be competitive. So that's why lowest possible cost. How can you do that? Like we have ThyroCare. ThyroCare gave the solution at the lowest possible price, and same was Honda when it had the price wars with the car makers all over the world. And it is always a quality product which is having lowest price wins in the market, right? So if we look at the down the history, hand tools enabled fabrication one, fabrication automation came little bit with water wheels, with steam engine, all that. Then with electric motors, smart fabrication came, and we have today smart bulk fabrication. Smart fabrication came with automation, robotics, and all. The smart bulk fabrication is because of the IST revolution, that is information technology and communication. Information technology, communication technology, are fueling the growth of smart bulk fabrication. How can bulk fabrication be smart? Can it be, can you produce just one part? Can a line system be changed so as to make economic order quantity one? It is a manufacturing company's nightmare. How can we make one of? The term manufacturing was born in the early industrial revolution. Before that, there was no manufacturing at all. So the term manufacturing was defined to represent making of bulk, not in few hundreds, thousands, millions. That's very important. So in order to make anything, we need to understand the art of making things. So early humans, when they tried to cope up with the hardship of the climate change, they were able to interact with the environment around them. If they want safety, they ran to the caves. And in order to protect, they had to fabricate a door, that became the first artificial thing to come. Many things came after that. They had to protect themselves, they had to kill, to have food, and protect themselves. And protection from so-called cold weather, they had to skin animals, fur, they had to make clothes out of them. I think it's very important that we go understand a little bit of these, where you have handmade, made using hand tools, because human hand was never, able to touch hot, touch cold, or fight an animal. So in order to cope up, the humans have to actually have a tool which is an extension of their hands, extension of their legs, extensions of their observation. All this, it made the mankind what we see today, an advanced animal, part of animal kingdom, right? And they've moved from handmade to made using hand tools, to making use of machine tools, to automated machine tools, and digital tools with the advent of computers. Some of these artifacts, what we see, are result of human activity millions of years ago, when they were hunting. After the hunt, they wrote something, they became the early records, early history, something which is kept as a reference even today, reminding how those people lived. People first wanted to drink water. If you want to drink water, you bring two hands together, and that is the form what they found most useful. So they put some kind of liquid water and moisture to work with clay by pinching what you see here, making a bowl. So bowl is nothing but a holded hand, which you can always use. But if you want to transport that, you cannot have it in hand. So they wanted more, in order to cope with that need of taking water from one part to the another part, long distance, may not be several kilometers, but short distance also. They were able to efficiently take using a clay pot. They also found making such pot by another method. So this is the creativity. Creativity is about not making different things, but making things differently, they say. And of course, we all know today we have a wheel by which we can make a pot. Thus goes the saga of handcrafting. Handcrafting gave rise to many artifacts. The humans used their fingers and they wanted to have extra finger. They took these, rods, which, they provided for extra finger, that is the beauty of it. And a finger which is like lady's finger, very short, the lady's finger vegetable, what I meant. You can see the crochet being done with those extensions of human hand. And we know how they cope with the weather. And soon it gave rise to the cottage industry. And these were having delays. So in order to increase the efficiency, they found mechanization. You can see here, this is a factory where you find no mission. People, they were doing the same thing at home, but now they are more disciplined. They are sitting in one place. And you can see there is a supervisor. There are people who are going to train them or provide them with material. The first factory was born. With mechanization, they were able to put enormous energy into whatever they are making. And in UK, we know this industrial revolution was born in the early 18th century. The textile mills, probably Bombay or any major city even in India, which was a colony of British, looked much the same way. Those days, landscape. Soon was born the production line. That is, one side the chassis moves, and this is from Ford. It looks like a cow shed, no better than a cow shed. But you can see the whole concept that one side, the chassis moves inside, they put on all the engine, all the things, seat, whole thing comes, and finally they put the four wheels and it is wheeled out as a car. So the division of labor, interchangeability, Taylorism, so many things came, and Ford gave the world the production line. Even today, for many cars, we need a production line which is dedicated. So we say this line cannot be changed because it is rigid, right? It is very rigid. We cannot change the line. So these were not flexible. But today's market, a place where customer can ask anything, right? We need to have agility. But manufacturing setup is such, it resists agility. So how do we get agility? That is the very important point we have to answer. with the advent of computing, a lot of things change. The controls could be controlled not by a mechanism which moves, but with a wire which runs long several kilometers. The electromechanical machine calculator, what you see, gave rise to miniaturization because of miniaturization of electronics. Soon, all such mechanisms gave rise to computing, computing as a new discipline. So the world had a different, better, efficient means of making anything. Designing became also very important occupation. In the early 19th century, Boas school came and they started, a new discipline called design, which is an iterative process. And you can see how any product we see undergoes a sea change. You may have hundreds of concepts generated, only one is taken and launched. So we call that as an iterative process. You keep on doing, and finally you will get to the end of the tunnel, showing some products getting into the market. That is very important. Now, how do we do that? And it used to take a lot of time. So that's why always the marketing used to be under the pressure called time to market. Is long. The NPD was introduced, new product design. And people used to validate the idea, because any idea taken is not good. The idea has to be tested and validated. Only then it becomes useful to business. If we launch any product and every idea I want to launch, then probably you'll become bankrupt. So idea, if it has some potential, need to be verified. How do you verify? Actually, you make it. So you can see the way people used to make things earlier, actually making a model, a mock-up model. In terms of electronics, you'll take a breadboard and assemble all the components and then check it out whether it works or not. If it is not, then that is where the learning starts. You will know what is going wrong. Then you correct them. Now you know how it is and you move forward. Well, with the advent of computing, people are able to do all these things much faster in a virtual world. On a computer screen, I can do any animation, any testing, any kinematics I can do today, because those are available, the small CAD and the big CAD, the computer-aided drafting, computer-aided manufacturing. CAM also was introduced, and the CAD, big CAD, computer-aided design was enabling people to do many decisions on the screen. But when you give this idea to somebody, I have tested in a computer, it works fine. Will you please fund me? Nobody will fund you, because unless you have a touch and feel, unless you see it in real with all its strengths and weaknesses, people cannot make a decision to fund. So if we look at digitization of manufacturing, it has been happening quite some time now, and people have started calling these as different revolutions. Revolution number 1, 2, 3, and 4. Nobody knew 3 actually, but when 4 was defined, they had to define 3 also. And 3D printing, or the so-called additive manufacturing, which we are discussing today, or digital manufacturing, is all part of the third industrial revolution, as you can see. But today we are already in the crossroads of industry 4.0. That means this is all not like a day, like a new year, New Year happens on 31st at midnight, 12 o'clock. You have the next year coming. So these revolutions are not like that. They're all blurring, They have a band of period which goes on. Today, with the big data analytics, cloud computing, Internet of Things, blockchain, cryptography, cybersecurity, all this, people are able to dream of a new age. We call sometimes metaverse. What is metaverse? Is it there? Metaverse is a concept again, Metaverse, a universe that is beyond what we see today. But that is in the making. Who is going to make it? It is you and me who will make it, right? And it is not there, but it has started. So some of the early contributions are AR, VR, mixed reality. People talk about metaverse, but there is no definition of metaverse. It is a new age wherein the transactions happen both in the physical world and the virtual world. You can see in the early days, we used to do machining, a lot of machining. It's wasteful. It will take a lot of energy to start with a large material bulk and go to a smaller form factor of the product or component, what you make. Producing a lot of chips, a lot of energy. This is called the subtractive manufacturing or conventional manufacturing. And so people were actually looking for an option. Well, there are many processes which we can call it as plus process, minus process, and zero processes. We'll not go into those details, but whatever we had before, we wanted to change from here, and that's where when people are looking at a easier option, is there a easy way out? So they say, kuch paane ke liye kuch kona padta hai. So when people are looking at this, a easy option, then they had to also take care of certain things. We'll see what are those. A new way of making things was born. So it's a regime where you're converting art to part. Or we can say a cat to part directly, very important. And how it is done? It is done, whatever idea you have, you create a virtual model on computer, then you take a software, slice it, and those slices are put back in the same sequence. These are slices. And this putting back is done by a robot. We call that as a 3D printer or a AM, additive manufacturing machine. And what is happening here? The digitization of objects started with CAD on one side, bringing the digital entity, which can be made in computer, you have to enjoy it, hold it in hand, was delivered by this technology called 3D printing, And so it is bringing a kind of a bridge between the virtual world and the real world. In the industry 4.0, we also call it as cyber physical system. Cyber physical system. So in the cyber physical system, the physical side is delivered by digital manufacturing. You see, I will not go into the details of this, but of course, 3D printing or additive manufacturing is misunderstood by many people, like how these blind people are touching the elephant. Some say, Okay, I have seen 3D printer. It uses a liquid. Now, some others will say, no, I've seen another 3D printer which uses powder. Someone will say, no, I saw a filament. Well, they're all right. They're all seeing the same technology, which has got allotropic forms or it has got different manifestations. But ultimately, it creates a physical entity from a digital data. Very important. You start with the digital data, you give it to this mesh system, it is going to give you a physical model. That's it. It can be liquid, it could be fire, filament, it could be solid, it could be powder, whatever. It is going to create an entity from a digital data directly to a physical data, which is as good as dematerialize and materialize it, right? And so there comes the definition, technology definition. What it says a 3D printing refers to a set of technologies. It is not one technology. Okay, it is a set of technology which helps to fabricate 3D objects layer by layer from a digital input data. Now, this digital input data could be a computer model done on a computer, or it could be a scan data, or it could be a medical image data. With all this, we'll be able to recreate the shapes or the products or the anatomy, which may be required for the businesses. So now let us have a quick comparison between the two. If we see the traditional process is lot inefficient compared to additive manufacturing process, which has less scrap and less demand on energy. And so that is very important. So let us take a deep dive in the technology, looking at the pioneers. Charles Hull, his humble operators, what you see there. And we have the first part made there. Of course, Dr. Kodama was the first person, but he could not secure a patent for his invention. He had no money. Well, Chuck Hull became the person who held the patent for selective stereolithography. And soon, a patent is given, it triggers new thoughts. When it triggers new thoughts, more people will look at it and they would like to build a new way of making things. So again, we had a new way of making things by Carl Decoid. He brought in selective laser sintering. Stephen Scott Crumb, a loving father for his daughter, in fact, along with his wife, they were worrying about how to fix a toy. How can I fix a toy which is broken? That led to make him discover or invent FDM, the filament deposition modeling. Of course, he hired some engineers to help him out and all that. But the motivation was his daughter, right? And he's not a inventor of normal kind, extraordinary, out of passion and love. Same thing happened with Walkman. Walkman was requested by Akio Morita's daughter, and Akio Morita orders his engineers to make a small form factor. Initially people say they refuse. It is not possible. Then he says, no, we need to do it. That led to the innovation, what we saw later. Of course, there are many of them. I'll not go into the details, but we should know how it works, So Chuck Hull worked with photopolymers. What is a photopolymer? Photopolymer is a monomer liquid, which is when exposed to light of a particular frequency, it takes the energy from the light and it will start polymerization. Monomer becomes a polymer. And when it becomes a polymer, because the cross linkage, it turns into a crystalline solid instantaneously. You can see a vat, it's a tank-like thing. And let us see some animation on this. So you can see the tank, which is the photopolymer. And as the optics scan, the material gets built layer upon layer, and then finally it is ejected out. You can see the ejection here. And same thing happens with a selective laser sintering, wherein a nylon powder is compacted. It becomes a sheet of nylon powder. When you expose it to laser sinters that. Let us see an animation. You can see how rollers roll fresh powder and it is exposed to mirror, which is reflecting CO2 laser, which is a heat radiation. So it melts selectively the powder. So let us see a zoomed version of the same thing, what is happening. So it is having a kind of a taco weld. The red particles are hot material because the impingement of the CO2 laser there, and the gray ones are the cooler ones. Nevertheless, this part, when it is made, it will be lot porous, permeable, right? So this is what happens in this particular technology, SLS. The parts are porous, so we need to do some treatment. For a plastic or for a metal, you have the same problem. You need to take care of that. So we can see how it operates, a kind of phantom writing the concentric circles is actually laser doing this sintering there. So layer upon layer, this is done in order to build the parts. And after a part is built, the cake is ejected, and you blow away all the loose powder. There emerges the product, what you have actually intended to build. Now, FDM, film fused deposition modeling, sometimes we also call it as material extrusion. You see here a Stratasys system on the top and one China-made machine up printer on the bottom. They produce a component which is almost same quality. What are the prices? The price of Stratasys Mission Fortis 450 MC could be 1.5 crores, while the one what you have Chinese, it'll cost you hardly anything, maybe in comparison, like a lakh rupee, or even if you are building your own, it will be as low as 10,000. One can build these printers. So what is the difference between the two? If you are an enterprise, you promised a customer, I will deliver it tomorrow with a lot of accurate parts tomorrow. Probably you will if you are using Fortis 450 MC. The bottom one may work very fine the first day, next day it may not work. The third day, again it may work well. That means it is highly, reliability is the issue with the smaller one. And you should be a real expert to run a smaller mission, because it will get stuck. It is not built with all the robustness, reliability. And so sometimes enterprises, they don't buy such smaller missions because it is a great risk. If customer gives an order and you cannot deliver, it is a great danger. And if you deliver a inferior quality product also, they simply reject. That means it comes back to you and you don't have any other option but to suffer losses. So normally industries buy a larger mission, which is also kind of a production mission, not an experimental or a maker plays. Makers buy missions. Makers are the people who can fix whatever problems may come. They may develop a new one, but getting a reliable mission deliver every time, working 365 days a year, 24/7 is very difficult. So you can see the one on the top is highly reliable mission, one in the bottom is highly unreliable mission. But if you are able to run, well, I think quality wise, they both can give almost same part, you know. You can see here, make about how it is building things. And of course, there are small, big delta versions of the same product, same technology, I can say, has emerged. And because of open source, we are able to find a lot of such missions in the maker community. Industry is still very conservative. They will not invest in anything and everything unless there is a value or why. So this is a technology where they used sheet lamination. We call it as laminated object manufacturing. This technology was so good, but somehow there is no traction. This company, Halicis, it became bankrupt. It was further copied in a different form. Instead of a laminate, M-Core uses paper, your A4 papers, glue it and then print it with color and all. Even this company could not actually sell well because there is no industrial application of this. It is not durable enough. Okay, so industry simply rejected. So it's a matter of time. So there is a new avatar of M-Core also, which people have brought in. Now 3D printing word actually is given to this technology called binder jetting. So what exactly is binder jetting? Binder jetting is, binder is a adhesive, a glue, gum. Okay. So supposing I have some gum and I pour some atta into it, the powder, and soon the powder absorbs all the atta, all the gum, and it becomes a solid. It dries as a solid body, right? And that principle is used here. They are going to have a liquid adhesive shown here in green. There's a print head, and they are going to have shapes of a particular section they need. Powder is put on the top of it. So powder transforms that layer into a sheet which is of that shape. And this is repeated once again, over and over again, to get the entire product out. In fact, we can get very colorful product. What you see here, a section of an engine. And but again, here, it is not very durable, you know. So you can see how it is done. It looks like a plan being drawn, ordinary printer, but as it goes down, you're going to build walls, roof, etc. And you can see it can also be printed with color. So you can see how it is going on. We are checking here. They're taking out the part, and you can see the final part. Well, this is material jetting or polyjetting or multi-jet, what we call. So this is for the first time, they started bringing a system which uses a digital material. What is a digital material? If you have tank A and B, by mixing different proportions of this at a 3D pixel level, what is a 3D pixel? 3D pixel is called as voxel. Voxel is the smallest unit where a 3D printer can build something, right? It drops, smallest entity is a voxel. And at that level, if I have tank A and B, if I can mix in various proportions, I can actually define that voxel, a 3D pixel, to have that property. And that is going to vary. So you can have a product which has got fully transparent to another side, fully opaque on one side. The other side, we can have it is very hard to a very soft one. Those things are all possible. So it is something like our own hand, hand has muscles and all, which is soft soft to touch, skin and all. But inside, we have a bone which is very hard, right? A hard tissue. So same way here, you can see a part floating in front of us has a black soft O-ring. It has got a manifold which is gray in color, which is quite strong and hard. At the same time, it will take, stresses. Then we have a button actuator, which is hard from inside, soft from outside to actuate. Okay. So the whole thing is built as one. The beauty of this is material jetting is you can assign properties of material. And what you have is a composite, a truly composite material, right? Which normally we actually go for some kind of assembly. So these will prevent any kind of assembly. Assembly needs poke, mistake proofing and all that. But here, there is no human interference. From CAD directly, you load it and you get the part. That way, beautiful. So this brought out a new concept called digital material, where the property from opacity to transparency, hardness to softness, you can vary and color 16 million colors one can use of. So that is the capability what you have with the technology. You can see here how paste-like material is coming out and it is exposed to UV light, which is green in color towards the end at the rear side. As it moves behind, there's a green color which is showing the laser. In fact, in powder bed fusion, the so-called laser travels several kilometers in order to build few gears. But you can see high-speed sintering on the other side. It is making bulk of things in a very short time. It's much more faster compared to the powder bed fusion. So I think the technology is moving towards that speed, quality. Of course, we also have directed energy deposition, which is called electron beam melting. Wonderful things, what we can make, like the glove here, which is not for surgery, it is for war, for example. One can wear this. Will not get a cut from the knife if it is casually come in contact. So here we see in metal powder bed, there's a lot of change, what I can see compared to polymers. In polymer, when you have a melt pool, it is not very heavy. Whereas in metal, this melt pool is of a higher density compared to the powder. So it starts sinking down. So there are a lot of techniques by which we address this. One of them is giving support, not only just support for the sake of support, but making tubes which are like heat pipes. They'll scavenge the heat out, as may be required. Otherwise, the whole thing will deform. It'll have a warpage, it'll have a cold shed, whatnot, all those things. You can see here how the metal, which is scanning, in order to complete the product, is seen here with flame. Flame is because the laser we cannot see by normal eyes unless we have a special filter or a scope. What you see here is its after effect. Well, you can see this is yet another technology where powder or wire can be directly used to melt as a small, bubble or not bubble, a drop. That drop is going to have a generation of many drops together. They are going to construct a product which is quite economical compared to other methodology. These are some of the printers, metal printers. They come in all shapes and sizes. And in fact, Bower, he brought in the new concept of parent and child, a 3D printer printing itself. So a lot of cartoonists also, they wrote many things in the early 90s, 3D printer print itself. The open source people, the Cartesian which was invented by the parents of a girl, FDM, as it came into the market, many people thought of alternate ways of doing the same thing. So here you have Delta, Polar, Scara, which are all very similar to what the original developers had done, except that they're made differently, right? So these are all, in some sense, they're all FDM avatars, right? But they work entirely differently. You can see Delta is different, Polar is different, Scara is different, as compared to XYZ, the Cartesian method, which is quite popular. You can see the open source also brought in new desktop options for us. And so much so, these are some highly reliable missions which are small. So investment is small. So you don't have to buy a big one. You can have a Form Labs mission, for example. Quite interesting, they're everywhere now. So you can see the development. So some company which is developing and bringing out new versions will win in this kind of market. So that way, Form Labs have been doing a lot of work. They have not disappointed the consumers or the customer, always with their good result, good consistency, low price. They are really disrupting, I should say. Of course, the aviation people also took over some of they acquired some of the companies like E-beam. E-beam mission was acquired from Sweden, and they also acquired this concept laser, which is of course now with a lot of funding has done a great job of becoming a great solution to all of us. These are all for metal and biomedical, metal implants and all. We go for these. What's so interesting is these systems are smart and they're Industry 4.0 ready. Of course, this is a very humble avatar of 3D printer. Well, I cannot say, can we call this as 3D printer? It's a big question, right? So you're going to hold it in hand like a pen or a glue gun. You're going to make the parts. Let us see how it is done. Now this one, what is the difference between this and this? This pen, if I hold it in the KUKA robot, the KUKA robot will become a 3D printer. That means if KUKA robot can take the digital input data and delivers it, then even this 3D doodler can be considered as a 3D printer. Right now, it is not a 3D printer because the idea comes from head, not from the digital data. right? Nevertheless, we can build some things, right? Like what they are building. Unlike the earlier one, this is a out-of-the-box 3D printing where you have the data from the computer coming to this, print head, which is depositing material layer upon layer. You can see there need not be any layers also. We can do away with layers. So you can see it is at an angle and it's still doing. Of course, large objects for aerospace applications are being tried. This is a company called Relativity, which is competitor to SpaceX. Okay. This is additive, not 3D printed. Okay, why I'm saying additive? Many times people think, additive. Okay, so it's just to bust it. This bundi, egg bundi, and there are many other bundis. Together, they form a laddu, right? And it's very important. Additive manufacturing is also assemblage of many things, right? So that's why we say it's additive, but not 3D printing. In additive manufacturing, most importantly, we have a control over each layer. Okay. For the first time, you would go for, to some extent, you can do that in casting. You can do it in, some of the activities where you can change, Now, you have a control in, to some extent in sintering. So I can have different material and sinter them together to get a bimetal or something like that. Whereas in normal manufacturing wisdom, it is not possible actually to have control over a particular layer. Now, this shows, how we are able to achieve control over a particular layer. And that's the difference between conventional manufacturing and additive manufacturing or digital manufacturing, what we can say. So you have a world of all these technologies. Added to all this is also bioprinting. So it's disrupting every sector: jewelry, medical, FMCG packaging, lifestyle, architecture, car, white goods, electronics. Well, we can think the unimaginable and make the impossible. These were not the words which were taken from the early industrial revolution. That time, probably one used to think how to think also, and think the unimaginable was out of question. Make impossible also was out of question. Okay, but today we say it is possible to imagine anything and get it made and use it. You can see the complexity of these. These are very complex, right? Did anyone design this? Probably yes, probably no. No means what? No means if it is a mathematical formula and you are going to substitute 1, n is equal to 1, 2, 3, like that, n times, you'll find that, the artifact which is there in virtually floating in front of your eyes in the computer is looking very interesting. You freeze it, save it as a file, and you print it. You get these, right? And so the complexity what you have cannot be handled by any other processes except additive manufacturing or digital manufacturing or 3D printing, which is a common name for all of them, right? So what for people are using it in the world? People largely use it for part consolidation. That means if you have 100 parts, you can combine them to make one component. Part consolidation, jigs and fixtures, rapidly helping one to develop, in half an hour time, a jig which can be used. It's quite popular. Need for lightweighting. Where is need for lightweighting? Need for lightweighting is there in all things which are airborne. That means they have to balance against the gravity, they have to move against the thrust. Thrust is there in forward, drag. Drag is the opposing force. It has to overcome and move forward. So mostly lightweighting was used in or thought of used to be used in aerospace applications. But with EV vehicles, which are retaining cells, which are before and after is same weight, but before charge and after charge, it will behave differently. So EV vehicles, wherein the dead load was more for the cars earlier, they had to optimize it. There's a need for lightweighting there. Okay. Now coming to another virtue of this technology is complexity it can handle. It can handle any kind of complexity. And also this is popular to make one-off part, and of course, body parts, be it bone or muscles, any other organ, we need to actually develop that, and we have done lots of such case studies, and what you see here in the foreground, a red little fellow, this printer is used to make the mammoth, what you can see behind. How do they do it? They do it by digitally cutting the mammoth, soft copy, into smaller chunks, which will go like a Lego, and they put some glue and build this elephant. Can you imagine? That's the beauty of what it can offer. So these are some of the advanced missions. Is the future of the so-called industry in future. And if you look at the pros and cons, you can see here it says both. 3D printing cannot give you bulk volume, it cannot give you. Whereas here we have complexity wise, nothing can match it. Okay. So in between we have injection molding, investment casting or vacuum casting, CNC milling in that order. But you can see we find volume can be delivered by these production machines. Injection molding. 1 second part will come out. That kind of approach you have. While 3D printing, you can see it cannot give you high volume, but it can give you complexity, any complexity. Very important. So let us play with the strength, not with this weakness. What exactly this shows is after having built the physical object in red in the middle, you finish it and that becomes a master. Then you have mold making. Of course, we cut a silicone mold, and when you remove the part from inside, the cavity is left behind. That becomes, the cradle for next part. So in 3D printing for additive manufacturing, particularly in jewelry, people with a CAD, they go to a 3D printer, printed in wax, then using lost investment casting or lost wax process, they make the parts. So it's an indirect way how to make this golden elephant. You can see it has got a lot of labels there. You don't worry about them now. But you can see what is the end result. So CAD to part, very important. In fact, the new generation is looking for some change. Now one size fits all kind of logic doesn't apply. The youngsters today, they want to tell the world I've arrived and I want to buy this. I want to have it customized. You know, some of these are very important aspirations which are driving, the agile manufacturing. They see somewhere and next day they want it to be made. They want to wear it. This has led to people having a lot of creativity, and so the so-called jewelry has become a fun object. So we know 3D printing makes a lot of sense to actually helping us out in various aspects of product creation. And today we talked about proof of concepts. So in a way, this is not product communication, objects, what you see here. It's a large butterfly valve, which is recreated just for an exhibition with cut section and all. So the whole thing is made by nylon. It looks as though it's real, right? Its whole thing is made by prototyping. So you can see here, some of these are made, this is a full-scale model of a car, and you can see capability-wise, these models are much finer. So it's a it's a headlamp of a car, it's a grill of a car. The top one is unfinished one, bottom is finished one. The entire door trim is here. Dashboard is here. So this is a case study wherein we develop a kind of IoT device designed by Elephant Design, Pune, and it was delivered with this kind of finish. So 3D printed part you see on the left-hand side, and finished part what you see on the right-hand side. So this is yet another product which is IoT based, and there's one more IoT based. When do we say there is a sensation? Whenever there is something connected with Bollywood or Hollywood. So that's where jewelries come into play. These are all some jewelry. You can see how it is transforming the very nature of the product because the capability. People have used the primitives, spheres, cuboid appear. Directly, they're linked and used as a jewelry. So very unlikely these things would have come without this digital fabrication. So we had a very fast development cycles, in order to make anything agile product. Agile means rapidly doing it, without any waiting period. So we did it when the LGBT community rights were announced from the Supreme Court. We immediately were the first to respond with such things as what you see here. And of course, with using this, we can do a lot of collectibles, and in lifestyle also, people are using many of these components. You can see PC is holding a design of the Black Lady with a blooming lotus. It is with a blooming lotus because it was probably heralding BJP is going to come. Well, you can see we made all the 42 trophies for 59 Filmfare trophy. It was designed by us, the lotus part of it, rest are all same. Well, The mass customization is a great term by itself. Mass gives the mass production advantage of getting a quality product, which is customized to you. Customized anything has to be charged more actually, but mass customization is that word which will bring in the beauty of both the worlds, quality and the so-called low price from conventional manufacturing to customization that is possible uniquely to every individual. And so we can see some of these are examples. I'm going back. Okay. Some of these are done using. You can see there is a ring which is having display. Aina. It is a AI-based individualization. One can do individualization. Even Razor Maker has started giving some options. So the new generation, the millennials, the Generation X, Asian, they are looking for something, They want to express themselves better. They want to design themselves, whatever they want to wear or eat or consume, So in that respect, this technology is going to be with us to bring the extreme agility that is required. Unique problems, unique solutions, and making it very organic. You can see here it's a compliant mechanism which has got no moving parts. It is a tongue, actuated. It's an actuator of a robot which can do the pick and place from one tray to the other, one point of the tray to the other part. As you can see, it works on compressed air, and the whole part is 3D printed. We have also done many things like this, trophies and all. This is interesting. It rotates. So you can see how people have been freaking out with the kind of transformations they can bring. So this is a way of having a typography which will resemble it will read two different things, messages in two different angles, and so are these. So this is called lithophane, which is also very interesting, and you can see how it becomes. If there is a big backlighting, the whole thing will show up as a positive. So this sculpture is actually installed in IIT Bombay. So the bottom, these hands are all 11 feet. The top, these hands are all 3 feet. So you can see these top pieces, what you see here, along with my colleague. So future of 3D printing is moving beyond prototyping to end user parts. So when we started early in 86, it was used mostly for making mock-up. And then there is a design validation model by 2010. By 2016, we have a component that can be actually used as a final product, end user part. That's how the whole technology is moving. So if you look at it, 3D printing is a small part of a larger spectrum of things. First, you should have an idea, then idea converted into 3D CAD, then it is exported in a particular file format to the 3D printer. 3D printer requires material, care, and further, you have post-processing, which will finally get packed and sent. That's the whole spectrum. And that brings out a host of applications. So you can see here how in medical area, this technology is actually disrupting. So you can see different levels. At the last level, you become a creator yourself. It's like becoming Brahma, giving life to things. Okay. But in between, what is the level 1, 2, 3, and 4, and 5? They're all under lab research now. Hopefully, in another 5 years, all of these could be available, including the so-called tissue printing could be available. Who knows? So you can see here how uniquely this is beyond CAD. It is not following CAD because the nozzle stops at a particular point. More clay is going to flow and it is again resuming. So this is a clay printer. Using a clay printer, one can deposit clay layer upon layer. Some of the artifacts made on this printer, you can see, it was developed by us only. So it is very great fun. If we want to understand, buy a kit for 10,000, 20,000, start building it, and you'll find that there are a lot of application you can start extending, So, well, they come in all shapes and sizes, what you can see here. And in fact, the bulk of 3D printing is done in the middle, medium, small and medium sized printers. Of course, there are many large format printers and also there are at micro level, people can also print things. But if you see individual designer, maker, artist would rather go for a cloud option because that would be very economical for him. Doesn't need to worry about anything. You just order and get it. If it is not good, you return it back. So this has brought out a new opportunity called as a cloud factory. Factory is where it is in a cloud. So you can just upload and get it delivered. That's it. So because additive manufacturing, 3D printing or digital fabrication, what we call, is able to make just one-off and still make profit, we say that this is best. And why it is for the new age? The new age aspirations are different. New age aspirations are a person want to have his own style shirt, his own style button, his own style food, for example. So manufacturing sometimes it deals with only bulk production. So how to handle such requests for one-off things? And that's where 3D printing will come into picture. So I foresee that the future is about hybrid, where a CNC machine, a 3D printer, a robot will come together in order to deliver whatever we see in this world today. It'll all be delivered by these three manufacturing pillars, main pillars, what we call as holy trinity of manufacturing. And design will lead to consumption. Manufacturing will be taken for granted. So it's going to be it will take a back seat. So I do not fix the problems. I fix my thinking, then problems fix themselves. So I think with this, we come to an end of my presentation. You can see, first of all, my advice to all of you is, if you want to 3D print anything, you should ask, why should I 3D print it? What value it is adding? Just because you have a 3D printer, don't 3D print anything and everything. It is not possible. So we need to understand what are the good things probably we can derive from this technology, where it fails, where it takes us to success. If entrepreneurs, you know it, then probably you'll not make a mistake of what others did, of having a printer, not able to use it, no ROI, you suffer loss. That should not be the case. I think all the startups, MSMEs, SMEs, they should look for a 3D printing partner, to start with. Learn, okay, then use it, then you start owning it, right? That's how it is. So by the time you can invest. Otherwise, people will put this capability in the wrong application areas. For example, somebody wants to have a metal printer. What is the application? They will make washers. So washer can be more efficiently done by piercing and blanking. Why do you want to go for that? So the area which is very important of going into details, whether I should do 3D printing or not, whether I should go for digital manufacturing or not, is very important for all of you. And that we call it as design for additive manufacturing. Okay. I think with this, I would like to come to I'll stop here.
Yeah.
If you have questions, I will take. It has taken a long time.
Yeah.
Probably I was
Thank
not
you.
able
Thank you.
to curtail just to.
No. I think we didn't know
more
the
knowledge.
timing. I think, thank you very much, sir. I think we are not able to notice the time part of it because the way you elucidated and all you explained, really we didn't notice the time. We really enjoyed the presentation, sir. We have small queries, like small thing, like this is with various materials, powder form and what you call liquid form and filament form and all. This is another industry. They got to manufacture those things and supply
Correct.
along with the mission. Could you highlight a little bit on that, sir?
Oh, well, yes, because I think it is very important. We have a whole lot of industry, especially during the COVID time. Industries got developed in India because there's the supply chain got cut from China, which used to serve that sector. So local manufacturing, they all came up. In Hyderabad, a lot of people came out with things. In Maharashtra, there are a lot of things. People put up their own shops, And I think even in the COVID time, there are a lot of requirement which locally were met. The Atmanirbhar Bharat was testing period was this COVID, and many of these missions delivered the so-called, the mask, the shield. They also helped in utilizing ventilators, by 3D printing the rarely available spares. Spares were also not be getting shipped, on demand. If somebody wants something, they could easily make it and use, that kind of opportunity was demonstrated in COVID time, So there is a huge opportunity in terms of mission hardware. It becomes saturated very soon, after some technology. But there'll be a lot of fine tuning going on, but still say hardware is like a saturated market. On the other hand, if you go, I think scope is there in software, where how to make this technology which can be even operated by a person who is not very learned, so that is very important. And so it de-skills, that is one aspect of it. Software's de-skill this, so that makes it easy to operate. And the other opportunity is real world needs real material. Real world needs real material. You cannot have only one material for every application. So that's where the material research has to is a huge opportunity, And so a lot of companies have pumped in a lot of money now because they see the potential. But where are we heading? Are we heading with in terms of speed anywhere near to the so-called conventional manufacturing? Probably no. Probably yes, because a lot of research is going on in that area. Slow and steadily, this technology is it will not replace conventional, but it is going to definitely give you that customization and much needed agility, which is hitherto not possible in the conventional manufacturing, and that's where I think it's very important to see that, we are going to have a hybrid, which will help. So it's a complementary role. All technologies, I love all technologies. The conventional, additive, subtractive, zero process, all are good. But they all have their own place under the sun, And industry has to know where to apply. That's where design for additive manufacturing is very important, because today we know how to maneuver the constraints of the old types. We have design for manufacturing, design for assembly, design for service, design for manufacturing, maintainability, all that things are there. But today you have this technology which is giving you a lot of freedom. Okay. You can think of anything, you can get it made, by this technology.
Dr. Guru Prasad, my name is
Yeah.
GMK Raju.
Yes, sir.
It's an excellent presentation. I think you really added value and knowledge to all of us. I just want to ask, in India today, which is the largest company in this space, and what type of turnover are they working with? Just some idea, if you have.
Okay. At one point, Imaginarium India Private Limited was largest, but this is a status which keeps changing, right? It is not going to be same all the time. Okay, I have some display issue. Okay, so today there are a lot of other companies also, having some kind of a specialization in metal, specialization in a particular area, dental. Okay, and even in the world, there are a lot of companies which are coming up. So the primarily 70% even today in the world's consumption, this technology caters to a prototype or design validation market. Okay. Now coming to the end user parts, which are going to be part of the M part, that is manufacturing part. There are a lot of opportunities coming, identified, and going very smoothly. For example, spectacle frames and all getting made, custom made. And these are, I can say, there are companies who are moving to from a local to a virtual platform, just like we ourselves, when I was in Imaginarium, we went on to build the cloud factory in 2016. During COVID time, we got the real worth for it, by takers, because it was like digitization, let us do. That was the kind of a thought what we had. But eventually, in COVID time, when the whole supply chain got disrupted and people were working from home, these cloud factories actually help platforms. So platform, in a way, it is a global platform. Anybody can access internet, has an access to that company. And once they make, and with global players shifting material from one part of the world to the another, it is like Swiggy, and you don't have to make anything now. It's going to be delivered to your door, right? So that is brought in. And I can recollect, some of these Indian players today are making something close to 100, 150 to 200 crores, turnover, and I think it is also going polarized in some of the things, like smaller quantity, higher value is got for, you can get it from aerospace application, medical application. Okay. Automotive is still very price sensitive market, but they use a lot of it. Okay. Aerospace, very niche market and high value, but risk are also very high. If there is a small change or inaccuracy, it will be rejected. So the maker will lose the entire value for it. He has to
I
redo.
see this as a great
So,
opportunity actually for a country like India,
yeah,
because you are giving now a tool for giving expression to our thinking. So, and MSME probably will play a very important role in this industry, because
absolutely.
it will
Yes.
all be small
Yeah,
people
yeah.
who come up.
Entire thing,
to-
ecosystem has to grow now by giving spares, by giving material, by giving software. And CAD becomes, easily portable and also secure. The CAD can be easily stolen. Somebody's hard work, just by attaching it and sending it to the world, you lose the control over it. So there are issues like how do you take care of the IP? And as and when the challenges are coming, new tools are also coming. Now
Sir,
the file
to-
security is also getting increased. Yeah.
So to ask another question, sir.
Yes.
Assuming that somebody would really venture into this, what would be the minimum project cost? Any product. I'm not saying it could vary for different products, different metal, plastics, etc., and all that. But somebody wants to go into this line for a specific product. What could the minimum project cost like? And are there any machine suppliers in India, sir, for this particular?
Yeah. There are a lot of suppliers in India, both the multinationals and major companies in India. India has a very proud, I should say, moment now. There are a lot of Indian manufacturers also, okay, who are playing at a global level. And of course, the suppliers like Imaginarium, they supply some of the best technology. There are many like that. MNCs directly they also sell. And there is a company in Bangalore, Intech DMLS. They made their own metal printer. In IISc Bengaluru and along with Wipro, they also tried some of the metal 3D printing efforts. And I know Bala, who is in Hyderabad, who also tried. He's one of the pioneers. Hyderabad. You have your own guy there. Bala is there, who is also trying to build. So he has done a lot of innovation, but coming to commercial scale, that is the one which actually one can reap the benefit. But you should be able to use it in a proper solution area. So you are asking a question: how much investment? So I will say, supposing I spend about 10,000 rupees, buy a kit and make a 3D printer, you can become an educator. You go to schools and colleges and show them how it works. So that is one area. Suppose you have time, you assemble more of them and sell with some profit. So I'll say starting anything could be as low as 5,000, 10,000 rupees. To that, if you are going to buy a reliable machine, you can give service. India has a lot of industrial areas where they require. And if you get even better material, then you will be able to serve a rare spare you can make, for example. People want to restore.
Yeah. Today, if you go to a pastry shop also, you find a lot of very innovative creations of pastries.
Correct.
So is it possible that behind the scene, these guys have a 3D printer which is actually creating those innovative
Quite
pastries?
possible, because we made our own chocolate printer some time back. You saw the clay printer.
You talked about clay printers, yes.
Clay printer, but the clay printer and chocolate printer are one and the same.
Correct.
Okay. Both will melt with heat, I can control. They almost look similar, So we have done Fudoni. Fudoni is a printer which Imaginarium sold more than 40 pieces to a 7-star hotel in Delhi. Okay. Fudoni. is a printer which prints. Well, all these things may not make the bulk of your food, it is going to create some kind of a stopper, So children come. So reason they go to a 5-7-star hotel to see, but they also buy many other things. So it's a kind of a attraction. But today it is all becoming an attraction and a store stopper. But I think in future, there could be space food printed, space colonies printed, because CAD has no weight, no payload, zero payload. It moves at the speed of light. And the beauty is, in CAD, there is no gravity. In CAD, there is no gravity, so you can think of many things, nested things, and then you can 3D print them. The 3D printer doesn't know there is something called CAD which has been made and they are nested. It doesn't know, no brainer. It prints a complex object, and complex objects sometimes, because of their rarity, the value is also high. And if they have a application like a gyroscope, it has to move in various directions. Such dexterity you cannot get by CNC, for example. Jewelry or medical things which are so complex, organic, cannot be milled.
Yeah.
They cannot be held.
So even in Hyderabad,
Yeah.
That the space aerospace startup companies, Skyroot and Dhruva, the young engineers, the co-founders,
Yeah.
they did about 70% of the defense components by 3D printing.
Correct.
And that's what they shared it. Like, they did what they did is that complicate shape, that sub-assemblies you specified it, the sub-assemblies parts, they've modified the design into some sort of a multiple, and they reduced the design part of it, material by, and then composition of material.
This
they
is
used
called
the
as
printing, and they made the components.
This is called as consolidation, part consolidation. So a component, a product which has got some 100, 200 parts can be fused together to make just one part. Stock number one. There is only one stock code. So the final product and the item are one and the same. Because today we used to use the conventional manufacturing. Wherever it is not possible, we used to cut it. And after cutting, we have to join them. So for joining, we have fasteners, nuts and bolts, rivets, welding, all that. Today, it is not required. So
most of the parts, do they require high impact compression? Because you were saying they will be porous and all that also, no, sir?
Well, so you need to understand that, depending on process to process, these parameters, what to take care, how to pre-process, post-process, and there are alternates which we could even go for. Sometimes normal plastic part may not be as strong as a 3D printed part, because 3D printing sometimes, it is like natural wood is not stronger, while plywood is more stronger, because it has got crisscrossing matrix of things held by adhesive, compressed. Same way in 3D printing also, they go for hatching inside, which are cross hatching, which will go zigzag. So you get really good strength,
Multi-directional, yes.
And today with HP, for example, has brought in multi-jet fusion. It is giving you isotropy. Isotropy is a property that strength is same in all directions, X, Y, Z, isotropy, we assume it in strength of materials. So they are able to achieve. Whereas if you look at 3D printing, it is a layer by layer, sandwich process. But sandwiching is for only limited to some of them. But supposing I have a layer and expose it to heat, you have a melt pool. Then the melt pool is like casting, and that's where they are able to maintain the so-called isotropy,
Something like fusion welding. Like, we have a fusion
Exactly.
welding or something.
In fact, they say very nicely, while plastic 3D printing arrived on scene in 1986 with Charles Hull's invention, the metal 3D printing has it has got 100 years of history.
Oh, yeah.
Because weld beads, when they are put one after the other,
Yeah.
they were able to make a kind of a check in the year 1927 or 25, or even less, earlier. So it's almost 100 years since this artifact has been made. What people felt welding is very weak, it is going to it will have a heat affected zone. It is going to bring down, there will be recrystallization, and there'll be, you need annealing and all that, no?
Yeah. That's
So
true.
it was considered to be very wrong thing to do, like a last resort to weld something and never depend on it, Today, the same thing has become a virtually a virtue.
Yes.
Every 3D printer, which is printing metal, is like a welding machine only.
Correct.
It is a foundry, right?
Yes.
And so,
Sir, one point. What is the surface finish generally for these components, 3D printed components compared to conventional, or can you go super finishing operation for all these 3D printed components?
yeah, that's true. So it depends on the technology. The larger the machine gets, larger the material deposited gets, coarser is the finish. So if you want to build, for example, they built a house in Chennai, IIT Madras people, even L&T built a house. So if you go and see those walls, you can easily make out the scale there, It is like a pipe, sandwich of pipes, how it appears. It appears that way. Whereas when I want to have a small part, which is printed at 100 micron accuracy, every layer is 100 micron. Okay. There you get a very fine finish. Jewelry, for example, we print at 16 micron accuracy.
Okay.
So where is 100? And, for example, FDM, it typically is about 174 or 178 microns. Okay. SLA is 100 micron. Multijet fusion is 80 micron. And if you go for wax printing and all, multijet fusion, 16 micron. If you go for, microstereolithography, one can go for 10 microns and submicron also. Nanoscriber, you go to 10 to the power of -9.
Oh, great.
Where you can make things which are MEMS, used in MEMS.
Yeah. Sir, I think this topic is so interesting. This topic is so interesting. I think we'll feel like to ask so many questions, and then we can engage you with this. I think I'll be contacting offline now. It's almost time is running short now.
Yeah,
I request our
Yes.
Ramchandra Garu to give the closing remarks, or we go to our guest speaker, sir.
Thank you, Sir.
Acha, Devendra Reddy Garu
He's
joined.
there, yes.
Please go ahead, sir.
I just talked a few minutes, sir, a few words.
In fact, sir, one of my friends from Hyderabad is also a startup who is into 3D printing called Kiran Soni. He started the journey and is migrated to Gujarat. And I'm into EV space. I'm also a part of one of startup. I'm founder of this one. And in fact, you took me to my old days of, the jargons what we used to use or acronyms of Xerox. We used to call variable data printing, what we call customization today. We used to call web to print way back in early 2000. Now we are calling it cloud factory. These are all things which are changing the names and changing the, the way we are doing it. And today, the customization, what we are known, in fact, in the market in Hyderabad for customization. And customization with 3D printing is happening not only at bakery, but also some of the vendors on tea stalls. They're printing your name on the tea.
Yeah.
The applications are from there towards your pharma,
Correct.
As you're talking about medicine, where we have already used this in dental application in Hyderabad at a dentist place through my startup friend.
Yeah.
And it has gone to even to manufacturing, even we're entered into DRDO labs also. And in fact, your presentation was innovative, and we felt like we were sitting in a classroom rather than sitting in any kind of a Zoom meeting or webinar. Now, Thanks for your time.
Thank you.
Sir. And
Thank you.
over to
Thank you so
President
much.
Garu. Over to President.
No, it's nice, sir. Actually, what Mr. Devendra rightly mentioned was it was really very suggest. And in fact, we were totally immersed in your lecture for more than 2 hours. I think it's the longest session we had this year.
Yeah.
I think no speaker talked more than 45 minutes or an hour. You have held us almost spellbound, and you took us into a different world. Most of us definitely, I think, must have got a great feel of what exactly 3D printing is, or the new inventions, new lines that are coming up. I think probably we'll have to engage you once again, sir. Request you once again to come out of forum.
No problem.
And
My
probably
pleasure.
more people will get benefit by your knowledge. You are absolutely dexterous, so ambidextrous. Everything you are able to talk so well. We are very grateful to you, and I think on behalf of HMA and all my friends, Devendra and Prasad, Geeta ji, and all other friends who are there, and all the members who are present, I extend a very, very, very thanks to you, sir. And I think we are immensely enriched by your wonderful talk. So we look forward to
My pleasure, sir. My pleasure. Thank you so much.
and thanks
Rajendra
to the
Garu,
audience.
for
They
the
have, in
opportunity.
fact, I would like to mention that almost 60 gentlemen were sitting across and none of them moved. All of them were through the session, entirely through the session, which speaks volumes of your the value of this particular lecture. So thanks to all each one of you who have been a part of today's program. Thank you very much.
Thank you. Thank you.
Thank
Thank you so
Thank you,
much.
sir.
Thank you, Prasad Garu.
Thank you. Thank you.
Thank you,
Karthik, you can close.
Devendra ji.
Thank you, Karthik.